How can we see the invisible? In highly unusual places, an army of small portable devices is already detecting what can't be seen by the naked eye. And this state-of-the-art technology is showing that the future can, to some extent, be predicted and prevented, with no need for a crystal ball. It's a silent, invisible killer that claims thousands of lives in Europe each year. But how can we detect it to prevent unnecessary deaths? Workers at this construction site in England are not alone among the rubble. Researchers have installed a small box and a computer. They're here to track the eventual presence of a fearsome enemy that's nowhere to be seen and doesn't smell: asbestos.
This is our prototype asbestos detector alert. It's currently plugged into a laptop, which does all the data recording and manipulation. This is displaying the scattering pattern from every particle that goes through the instrument. In here it's quite dusty, but it's random dust rather than being fibrous, so we're not seeing any fibres at all. It works by drawing air in through this inlet into a chamber where a particle is illuminated first by one laser, and the scattering pattern from that is captured. It's then exposed to a magnetic field, which preferentially rotates asbestos fibres against non-asbestos fibres.
When exposed to magnetic fields, asbestos fibres react in a very particular way. They rotate. Researchers match that property with laser science to develop their device.
This fibre is about 1,000 times larger than an asbestos fibre, but when we introduce it to a laser beam, it illuminates in exactly the same way as an asbestos fibre would, creating a very, very similar scattering pattern.
Their work also involves dealing with real asbestos fibres, risky research techniques that are now possible thanks to huge technological advances. And not only that.
The primary reason that this hasn't been done before now is funding issues. Lasers were very expensive and computing power was very expensive. So you couldn't make something cheap and portable that people could take out into the field and use. Now lasers have come down in price and computing power has come down in price.
Back to the field test, researchers are confident their prototype works. Now they're looking ahead.
The next step from this prototype is to remove the laptop to have some internal electronics doing the data analysis. After that, we'd like to increase the airflow so that it will look at more particles per second, and we can get a larger proportion of the air in a room through the instrument more quickly.
We have already in mind a handheld version of Alert. We feel that we need to have a unit that is worn, so when a contractor is drilling and hammering, it breathes the same air that he breathes. That would give a vibration and an audio alarm. It only takes one fibre to be inhaled to do substantial damage. So you want to avoid, wherever possible, to have contact with airborne asbestos.
But sometimes seeing what's invisible is not just a quest to avoid danger. It can also be a quest to improve wine quality out in the fields. At this vineyard in Portugal, a different type of grape harvest is underway. Researchers are testing a small device called Wine Pen. It can, quite literally, write down what's deep inside the grapes.
This is a very useful tool. It allows us to measure the ripeness of grapes on site and in a non-destructive way. We can very quickly measure the levels of sugar, acidity and polyphenols inside the grapes. The device has an integrated GPS system, so we can take different measurements as we walk the length of the vineyard. We can then manage the vineyard, taking into account this data.
The device works by measuring the natural response of grapes and their molecules to light. Data provided by the pen is then uploaded into computers, linked to mathematical models, and finally translated into maps that can also be read on portable devices.
So this is a map that shows the distribution of sugar in the grapes at one particular vineyard. The scale goes from green to red. Regions in green show low sugar content inside the grapes. Regions in red show the areas where grapes have the highest concentration of sugar. In this particular case, we see that in one region there is a lower sugar concentration, so wine growers can make a more informed decision to produce a certain type of wine. But there is also a region in the vineyard with a much higher sugar concentration, where wine growers can decide to produce another type of wine with more alcohol, a more vigorous and structured wine.
And wine growers, of course, welcome this with open arms.
This way, we don't have to spend our time taking grape samples from each plant, then taking them to the laboratory for analysis and having to then wait for the results to come back to us. It's a really slow, painstaking process that we won't have to follow anymore thanks to this tool. So we can have the results in real time and we can plan our grape harvesting activities from one day to the next.
The device was developed during a European Union research project. Scientists now plan to improve the technology under the so-called Horizon 2020 framework programme, the new financial tool for the advancement of research and innovation in Europe. And researchers are not short of ideas.
The device has to be more ergonomic. In the future, we would like it to be better adapted as a handheld instrument. And we also have to keep working on improving the sensor. It is an optical sensor, and the light will often interfere with the readings. So we have to make sure that the sensor is well focused on the grapes it has to measure. We need to try to minimize the light's interference in the readings we take with it.
And small, easy-to-use devices, which are able to see the invisible, can be used for other purposes too. Sometimes tiny portable technology can also prevent food poisoning. At this institute in Germany, a baker is taking a hands-on approach in the name of science. He's cooking traditional bread with cereals, some of which have been imported from India and China. Their labels certify that they comply with strict EU legislation on pesticides, but bakers often still have some doubts.
Our suppliers guarantee that the imported cereal is pesticide-free, and we are sure that in 99% of cases this is true, and the quality is good. But of course, we would like to be 100% sure. That is why it's important, and we would like to be able to verify this by ourselves.
In order to do that, researchers have developed a device designed to quickly detect some pesticides in cereals. The prototype was built upon research done by Greek scientists, and it's based on complex biological and chemical processes. But its use is very simple, according to scientists.
The system registers the reaction between antibodies and living cells. Then this data is forwarded as an electronic signal to the machine where it is processed. The result will show whether or not the sample is contaminated. The system is developed with small and medium enterprises in mind. It is important that they have easy access to it. No great skill is needed to use the system. In fact, any employee of such a business can use it after a short training course.
The samples used in this test are identified as pesticide-free. The baker can indeed bake his bread. He says he'd be happy to invest in a device like this, and he sees other invisible substances he'd like to keep an eye on.
It's very important to improve this technology so that we can verify if other toxic products are in the raw material we make food with. Products such as heavy metals, for example, so that we can sell healthy and clean produce to our customers.
Gesund und sauber sind.
Customers and citizens, researchers conclude, have everything to gain from their efforts to see the invisible.